Hello, I am Jyne and Catipay from grade 12 camp, and this will be my first performance task in physical science. Today, we are going to learn the historical development of atom and the remarkable scientists who had a big contribution to what we now currently know about the atoms. John Dalton was the first scientist to develop an atomic theory based on scientific observation. John Dalton was an English scientist. He is often referred to as the father of atomic theory. In 1803, he proposed the theory of the atom. He believed that all matter is made of atoms. Atoms cannot be broken down further. Atoms within an element are the same, while atoms from different elements are not. For example, hydrogen atoms are different from oxygen atoms. Atoms are rearranged during a chemical reaction, but are not lost. This is called the law of conservation of mass. Compounds are formed when atoms form two or more elements combined. In any one compound, the ratio of the number of atoms to one another is a whole number. This is called the law of multiple proportions. For example, in CO2, the ratio of carbon to oxygen atoms is 1 to 2. Dalton's theory didn't get everything right. For example, it was later confirmed that atoms can be broken down into subatomic particles, known as electrons, neutrons, and protons. But it was a great start because atoms and molecules are still the smallest particles a substance can be, and still retain its chemical and physical properties. J.J. Thomson J.J. Thomson was an English physicist who is credited with the discovery of the electron and proposed the plum pudding model of the atom. Part of Dalton's theory was disproved when Sir Joseph John, or J.J. Thomson, discovered the electron in 1897. Thomson used the idea of radiation, energy that is transmitted in the form of waves, particles, or rays. Using electromagnetic radiation theory, Thomson built a cathode ray tube to prove that negatively charged particles or electrons were present in atoms. A cathode ray tube is a closed glass cylinder in which most of the air has been removed. Inside the tube are two electrodes, a cathode, which is the negatively charged electrode, and an anode, which is the positively charged electrode. When a high voltage is applied between the electrodes, a beam of electrons travel from the anode to the cathode. Thomson was able to determine the ratio of electric charge to the mass of a single electron. Thomson imagined that atoms looked like a bowl of plum pudding, meaning the electrons just sat in the pudding of protons. The negative charges of the electrons were cancelled out by the positive charges of the protons. Ernest Rutherford a British physicist, took Thomson's idea a step further by using radioactive particles. He shot positively charged alpha particles that are made up of two protons and two neutrons, through a piece of gold foil. He noticed that some of the alpha particles went straight to the foil, but others bounced back. What would cause the alpha particles to bounce back? Rutherford theorized that atoms are made of mostly empty space, which is why most particles went straight through the gold foil. Atoms have a positively charged center, which caused the positively charged particles to bounce back. His second idea came from the theory that because like repels like, meaning positive charges repel positive charges, the positively charged alpha particles were most likely hitting the center of the atom, which was also positively charged. He named that center of the atom the nucleus. Nucleus, a positively charged central core of an atom, contains nearly all of its mass. Electrons are matter. All matter has mass, therefore, electrons must have mass. But how do we measure the mass of something as small as an electron? In 1909, Robert Andrews Millikan, or R.A. Millikan, performed an experiment in which he was able to find the size of the charge on an electron. R.A. Millikan was an American physicist who received the Nobel Prize in Physics in 1923 for his work on measurement of the elementary electric charge. He was able to do it by his oil drop experiment. Millikan placed a negative charge into a drop of oil. He then determined how much electric charge must be applied to suspend the oil drop in an electronic field between two metal plates. By balancing the gravitational and electric forces on the oil drop, he could determine the charge. After multiple experiments, he found that the charge on an electron was this. Using Thomson's charge or mass ratio of the electron, Millikan determined the mass of an electron. The charge of both the electron and proton, known as the elementary electric charge, E or Q, is this. Because Rutherford knew the charge of the proton, he could plug it into his equation and calculate it in reverse to determine the mass of the proton. Lastly, James Chadwick. James Chadwick was a British physicist who discovered the neutron in 1932. He was awarded the Nobel Prize in Physics in 1935. James Chadwick spent his life studying the nucleus of the Rutherford atom and found the mass of the nucleus to be twice as large as previously thought. In addition, Chadwick noticed that the Rutherford atom was neutral, yet the protons had a positive charge. These pieces of information led Chadwick to theorize that there must be small particles other than protons present in an atom's nucleus, ones without a charge. He named these subatomic particles neutrons. And that's pretty much how we understand the atom today. Anyways, that's everything for this video.